This is a recursive sort. This one's pretty difficult. I would say this is going to be the first very challenging thing that I'm going to have you do during the body of this course. So if this feels hard, it is hard. So I just want to give you permission beforehand to be okay that this is going to be hard. All right, so let's apply recursion to sorting a list. Kind of like insertion sort, where you assume that a list of 1 is already sorted. We're going to take that and we're going to apply that to sorting. So the idea here is that we have a list of length 10, and we're going to take that and break that into 2 lists of length 5, and then break that again into lengths of 2 and 3, and then eventually you're going to break everything down into lists of length 1, right? Using recursion. Once you arrive to a list of length 1, that list is sorted. That's the base case, right? So you return that list of length 1, and then you're going to stitch together in a sorted fashion the 2 lists that are coming back, right? So if I get a list of length 1 and a list of length 1, those are 2 sorted lists, and then I can write a merging function that's going to take 2 sorted lists and stitch them together. So let's see if I can kind of show you this a little bit. So let's say I called merge sort on this function here of 1574236. Okay, I'm then going to call merge sort on 1574 and 236. Okay? And then I'm going to do this part first, right? Because that's how the recursion is going to go, right? It's going to go down one side, and then it's going to kind of go through the various different parts of the tree. Okay? So I'm going to take this list merge sort 1574, and that's going to be broken down into merge sort of 15, which will also be broken down to this, but we'll do the first one first. Then that's going to be broken down into merge 1, merge sort of 1, and merge sort of 5. So you can see here we're 3 levels deep in our recursion. Okay? So far all we've been doing, we haven't been doing anything other than just breaking big arrays down into smaller arrays. Okay? So we hit here, 1 is of length 1. This is the base case, right? So this level of recursion is just going to return back up. So it returns the sorted list of 1. Okay, then it's going to call this one over here, merge sort 5. This is of length 1. This is the base case, and it's going to return, right? So now we have merge sort on both of these from depth 3. They're going to be returning back up to depth 2, right? And so now we're going to call this merge function. Notice that merge sort and merge are slightly different. Merge sort, this is a recursive function. Merge is not a recursive function. Okay? Merge is just a function that you're going to write that you pass in 2 sorted lists. Now, I'm extra emphasis on sorted, right? It has to be already sorted, or all of our assumptions about this are going to break down. So what merge does is it just, again, merges together 2 sorted lists. So basically you just iterate through both of those lists and say, all right, is 1 or 5 smaller? 1 is smaller, add it to the sorted list, right? So once one of the arrays is empty, then you can just add everything on the right array. So in this case, it's just 5, right? So then we return back here 1, 5. That's a new sorted list, right? That's what that merge algorithm does. It just takes 2 sorted lists, makes 1 sorted list, returns that. Okay? So now we have this sorted list of 1, 5. Notice that that's actually originally what it was, but it doesn't know that until it's actually run the whole gambit of merge sort. Okay? So now it's going to pop back up to here because this part returned, right? Merge 1, 5, due to how recursion works, right? This is now finished. It's returned back, and it returned this 1, 5, right? So now we're popping back up here to depth 2, and we're going to run merge sort on 7, 4. Okay? So that's going to get broken down again to merge 7 and merge 4. Sorry, merge sort 7 and merge sort 4. These are going to both hit base case there, base case there. And then those are going to get returned back, and that's going to merge is going to get called on this list and this list, right? So you're going to ask the question, is 4 or 7 smaller? 4 is smaller, so you get this in the new array. Right array is now empty, right? This one's now empty. So we can just blindly concatenate everything that's left in the left array. That's just one item, right? So now we have 4, 7. Okay? Now we return that back. That gets returned back up to here, right? This level. So now we're going to call merge on these two lists, right? The 1, 5, which we got from up here, and the 4, 7 that we got here. Again, very critical. These are both sorted, and we know that. Is 1 or 4 smaller? 1. You add 1. Is 5 or 4 smaller? Because we're just going down the list here, right? So we go to here, and we're comparing 5 to 4. You say 4 is smaller, so we have 1, 4 here. Then you ask, is 5 or 7 smaller? 5 is, so you get 1, 4, 5. And then left array is now empty, which is because all that's left is 7, right? And then you just add that to the array. So now we have a larger list of 1, 4, 5, 7. Okay? And it's just this, right? All you're doing is breaking everything down to small problems and building them back up, and you're building them back together by using merge, right? I also see people call merge stitch, right? Because you're stitching together two sorted arrays. So 2, 3, 6, that's going to get broken down to 2 and 3 and 6. 2 and 3, 2 is base case, 3 is base case. Then we're going to call merge 2 and 3. Then out of that we get return sorted array. This should be 2, 3, not 2, 4. But yeah, 2, 3, right there. Merge sort of 6. That's a base case, you return that. So now we're going to merge together 2, 3, and 6, right? And by the end of that, we get return the sorted array 2, 3, and 6, right? So now we're back up to the point of here at the beginning. We have merge this and merge this, right? So that's what this is. And this is where we get our really big stitch together. Is 1 or 2 smaller 1? Is 4 or 2 smaller 2? Is 3 or 4 smaller 3? And you can see together this gets stitched all the way until up it is that the right array gets empty and we concatenate everything in the left array, and we end up with 1, 2, 3, 4, 5, 6, 7. So that was a long journey. Thank you for sticking with me. But like, that is the entire algorithm, right? You have two functions. You have merge sort and merge. The only thing that merge does is it takes two sorted lists and makes one sorted list. That's all merge does. It's totally blind to the rest of the world. Doesn't care, not recursive. It's just one simple function that takes two sorted lists and makes one sorted list. And then you got merge sort that all does is it breaks big arrays down into small arrays, and then it concatenates the things that come back from its merge sort recursive calls and passes those into merge. So here's kind of a visual representation of it. And you might be asking, does the left array have to be bigger than the right array, right? This one is length 4, this is length 3. It doesn't matter, right? You can even be inconsistent. It doesn't matter. Okay, so this breaks this down into eventually lists of length 1, and then it stitches them back together until eventually you end up back here with a sorted list.